microprocessor interfacing. So in the last class, we have learned the basic about MCU, the definition of MCU, and the overall concept of this course, how it works, and how we're going to interface all these items. Okay, so the most common phenomenon is that for this course particularly is this kind of board. I've already get to know about this board, that is Arduino board, and there are different types of cousins of it. Okay, like say it's Arduino Uno, and there are different types of board like Arduino Nano. Okay, Arduino Duo, Arduino Mega, Arduino Mini. Okay, so these are the cousins of Arduino board basically. What is the purpose and how it works? Before jump to this section, let me introduce its basic part. Okay, so first of all, how we can utilize this board in a particular system or in a control system, as you have come to know about the design of smart tank based monitorization. Okay, if the level of the water goes up, or consequently it will rise apart from the tank, then you will get notified in particular 3 conditions, and you are going to put some values and you are going to take some inputs according to the water level, and after processing the unit or processing the system, it will notify you notify you with an alarm, with a light or whatever it is. Okay, so can you please say something or any kind of example that can be used, that can be proper utilization of Arduino or anything? Any kind of system or any kind of example, any kind of.
So our home appliance like TV, fridge, and washing machine.
Not overall, just take a simple one like TV, or just have a look at your fridge. How? Okay, let's say you are going to choose the fridge and you want to make this system very smart, or you are going to make the system IoT based, or you are going to make this system like you are going to manipulate it in your own way. So where you are going to put this Arduino board, and which purpose you are going to use this Arduino board, and what is the output of the system to that particular fridge. Okay, you have captured a very nice example. So let's say here is a fridge, okay, and it has 2 different parts, 2 different compartments. Here is the iceberg, where we will put the meat, chickens, beef, fishes. You just want to cool down within 0 degrees Celsius to 20 degrees Celsius, or make a particular spicy ice. Okay. So the second floor is for the normal condition, like not to make any deep freeze, just to make any standard cooling system where you can keep your vegetables, eggs, or any sweets, fruits, whatever it is. Any water, okay, not too much cold, but just to drink for the regular purpose. Let's take an example of a egg. Like you bought some eggs. How many? 4, 5, 8, 10. How many eggs you have bought? 12. Okay, so it's 1 dozen, right? So you have a very less memory while counting eggs, or you are just not concerned about your foodstuffs. Okay, so there are 12 eggs you just keep, and you are thinking about that. Okay, I will take a half boil today, a full boil at night, and there will be some thing that I will put my egg to the noodles. Okay, and after that you have seen that there are only 6 eggs after 2 days. So you can't count them or you can't monitor them in your own way. But if you want to actually monitor that particular scenario, this Arduino board be implemented to the particular system? Yes. Your answer is yes. How? I just need the proposal. I just don't need any kind of specialization. I just need the proposal that in that way it could be input, it could be output. So here comes the Arduino board. Can you please explain where you can put it for the particular X?
We have 12 case.
Very good. We have 12 different cases where we can put those X.
If we implement a sensor.
Nice. If you implement a sensor, okay. Then
Or laser light.
Laser light, okay.
Who is counting this fill up point or
okay, so does the camera cover the full board? Okay, I'm looking good. I'm looking good or okay.
okay sir.
Okay. So let's see. So you are saying that here will be a case 3, 4, 5, 6. Okay, and there will be another part that will be half of them. 6 plus 6 is equal to 12. Okay, so you are going to put the X and you told about the sensors. Okay, let's put it down to a box. And what will you do about that after implementing the sensor? Then what?
This sensor counting this egg and when we keep one egg and
Okay.
this case is
Okay. Sure.
স্যার যখন আমরা হচ্ছে এগুলো থাকবে আমার ফুল যখন আমরা ওখান থেকে একটা এগ তুলে নেব তখন খালি জায়গা হয়ে যাবে তখন সে এই আর্ডিনোটা সেন্সরটা বুঝতে হবে এবং সে একটা সিগন্যাল আর্ডিনোতে পাঠাবে এবং কাউন্ট করবে যে আমার একটা ডিম খালি হয়েছে বা একটা বক্স খালি হয়েছে
Okay.
এভাবে সে কাউন্টিং করতে পারবে
So how we are going to take that value or we can watch or monitor that value?
আমরা যদি একটা ডিসপ্লে ইউজ করি সেখানে
Nice. Okay. So overall, the answer, I mean, the gist of your ultimate proposal is you are going to put a sensor over there. The sensor will take the value of X, that whether they are present or not. If they are present, then it's okay. If they are not present to this particular case, then the ultimately processing unit will process all the stuffs and show the value present or non-present or present or absent, a number of X at there or number of X that was not present at there. So it will, I mean, portray to the display. Okay. So can we say that the display is kind of the measurement of output? Yes. The measurement of output means the output, the LED bulb. Is it output or input?
LED bulb output.
Output, because what? It emits light.
Yes.
Okay. The alarm is output or input? It's output. The LCD display or LED display? Output. So the display is ultimately output. The sensor, when you take value,
Input.
is it input or output?
Input.
Input. So there will be 3 boxes to define the ultimate system. Is the input is taking the value, the processing unit process all the stuff and show the result to that particular output arena. It could be a bulb, it could be the motor, and it could be the display, whatever it is, but it will show the output in the result of the component that we are going to use in our daily life. Fine. Okay. So we got our ultimate result in just one line is f of x is equal to 4x plus 10. Can you say f of x is equal to y? That you have done in your maths in your earlier stage.
Yes.
Y is equal to f of x.
Yes.
So ultimately the y is depends upon the value of x. So the result of the output is depends upon the input. If there is egg is presenting or there is no egg at there, so it will calculate the value and show it to the output.
Yes.
So ultimately, if you put the x 2, then you will get what? 4 times 2, 8, 18. If you put the x value of x is 3, then you will get the different value. So ultimately, the display will show the different value according to the input as the function. So ultimately, to define, to say in a nutshell, you can say the ultimate result is a function. Okay, and this equation is the ultimate processing unit that microcontroller used to do that. So to understand this thing, you have to know about the maths, but don't worry about that. We're not going to execute or implementing any kind of methods that were the mathematical algebra or equation is not going to discuss in this course. Just for an example, we took that function and we can relate to the function to our ultimately system. So this controlling unit is the most important because the input and output is totally connected to the middle area, the middleman, as like our brain. Okay, so that's the scenario, or that's the gist of the last class, that we have come to know about these equation functions and the ultimate result. So your example of the egg is very good, and to make it more compact, we can say the sensor, it could be IR sensor.
Yes, IR sensor.
It could be a load cell. Okay, so how it works actually? The IR can show different value according to the ray of the light. So if there is no A, there will be one value, and if there is A, so there will be different value. Okay, so according to that value, the processing unit will do what? He will calculate the value according to your codes. Okay, so there is a difference between codes and sketch. We are going to jump to this section later. But according to your lines of the codes of the sketch, the processing unit will process the number. But you have to show, or you have to monitor the value. Okay, so to know the value, to get to know the ultimate counting number, we had to put a display over there. And that display is LCD display or LED display, or your mobile phone can be the best display for this purpose. Okay, so there you can use some Bluetooth module, AC05 or something, and you can get your ultimate result. So that's the ultimate scenario for our microprocessor interfacing course. Here, basically, they interface the component with your particular sketch and show some ultimate result that is very beneficial and that makes our life very easy. And here comes the ultimate role for the electrical electronic engineers. Okay.
Yes, sir.
Fine. And we have talked about the cousins. He has a very good family, like Arduino family. He has Uno, Nano, Mega, Dio. So this family depends upon the variation of work. And let's say if you want to work with sound system, to put some extra more effort in amplifying, to work on something that is more accurate, okay, in vocal or in noise reduction, then Arduino Duo can be the very good choice to work on that particular purpose. Let's say it's very common that the test player, one-day player, and T20 player can never be the same. You can have a try with the test player to the T20 player, but their batting style, their mindset never going to be same. So it's totally different. The T20 player is a very aggressive approach batsman, and he or she has to play like that way. And T20 and a test batsman have to play some dot balls that they can hold on the wickets and make some good partnership. That will be the benefits of the team. So you have to think of the benefits of the team. So you have to think about the ultimate purpose of your work, what you're going to do, and you have to make a clear vision of that. When you have a clear vision, like, okay, I'm going to count down the eggs, and there will be no ultimate output that have a very high amount of current consumption, high amount of voltage. So let's take apart, let's keep it aside, and we can work on the Arduino Uno board. That is very common. And you need lots of analog and digital pins and some communication system like I2C, SPI, or whatever it is. And ultimately, you need lots of pins. You have to connect the display, you have to connect the motors, you have to connect two LEDs, one buzzer module. So, do you think that these pins are enough to connect and to wrap up the whole summary? If there is lots of, there is uses of lots of pins. If these limited pins are feasible to do the ultimate task? No. So you need the Arduino Mega because he is very very big and I mean very weighted person. So he has lots of pins and you can execute your ultimate task to that particular Mega board. Okay. So that's the utilization of Mega board. And if you want to make some compact device like a wristband, okay, the values will be matter, but the fact is your size is the most important thing. So Mega is big in size and very weighted value they need to provide you. But if you need to compare any something like a wristwatch, a small device, so do you think that Mega is the best option to choose to do the ultimate task? Ultimately, the result is no. At that time, you need to choose the younger or the small brothers like Mini or Nano. So that's the not none of your business to think about the pin numbers. Oh, I need that kind of pins. Oh, I need lots of pin numbers. So that's not your concern. You have to think of the size. Okay, so that's how it works. Lock down your vision, close your ultimate task, think what we are going to execute. Ultimately, you have to choose that kind of code. So the code will be the same, but the board will be varied. Depends on your work. Okay, so I'm not going to explain all the stuff, but as I have just opened up this Arduino board, so let's play with that. Okay, here a black chipset has been marked. Chipset has been marked, and if you take out from the Uno board, that's the Arduino Uno board, and you will find something new. The new is something like that. This point or this chipset is called ATmega 328P. ATmega 328P. 328. So this chipset, this IC has been put down to the Arduino Mega and as well as Arduino Nano, as far as I know. Okay. So the fact is there are another unit that is this black stick and there's a regulator. So the whole task is going to operate with this one, and it is erasable, or you can play with it like plug and play. Okay, you can connect it with like plug and play. Let's say it's this burned down. You go to the market, buy this chipset ATmega 328P, send the money through Bikash or Nagad, whatever. They're not going to sponsor this video, or by cash. 720 taka will be the maximum value of this price range of this ATmega 328P. So you will get it and put it to your Arduino board, and it will work as the previous one. And the most fun fact is, in some board, if this IC is going to burn down or is out of reach, apart from that, it will work as a normal condition, because there is, in some boards, this chipset has been soldered in the basic. So if you want to buy the boards, you need to select whether this is erasable, I mean plug and play system, or that has been soldered fully. So the soldered board, I mean fixed board with the particular IC is less in price. So if any kind of error or malfunction and it just boom, okay, then your Arduino board will be what? Listed out or destroyed, or you can do anything with this board. But if you can buy the plug and play system, then you will go to the market and buy some another chipset and you can work on that. Okay, so in Bangladesh, we are very familiar with these two kind of boards. Okay, I will obviously get to know about this chipset and how it works, and gradually we will go to the further approach to get to know the other components of the Arduino board. Okay, so let's say this is the ATmega 328P. Could you please notice that there is a black mark?
Yes, sir.
And there will be nothing? Okay, so it's something like that. Okay,
Yes,
so if I go to the previous page, this part is something like that. So the chipset, you can rotate it like this way, but if we're going to set it down at here, you need to look and very carefully to that part. So how? Because the pin number 1 to 28 will vary to its particular rotation.
Yes.
Now, so here comes the 1, 2, 3, 4. Okay, I have marked it already. 1, 2, 3, 4, and the side one is a 28. Okay, and this goes gradually from 1 to 14 and 15 to 28. Ultimately, each side contains 14 number of pins. I mean header or legs, whatever you say. This particular indication refers to a different number, refers to a different block, that is B block, C block, and D block. Okay, D block, B block, C block. And these blocks indicate the ultimate pins that is connected internally to the Arduino board. I mean, these pin numbers are connected to the blocks, these blocks, and these are the number of legs that indicates to the ultimate blocks, and these blocks refer to the pin numbers of Arduino. Okay. If I say pin number 2, so that doesn't mean that this number of 2 or this leg indicates the actual number of 2. So how are we going to know about that? Because we are very familiar with the Arduino board, but the Arduino board is not made in a day. Rome was not built in a day. So that was the first thing that has been built by the scientists or the engineers, and after the gradual approach, the board is a compact solution. So that solution is come to very easy because these pins number are not concept of ours. Okay, because they are internally connected with that particular pins. Okay, they are connected with the particular pins. So this MCU microcontroller unit is the ultimate 18-3 PU. And if the question comes to you that how many pin numbers contain to the C block? Okay, let's count down. 5, 4, 3, 2, 1, 0. 6. 1, 2, 3, 4, 5, 6. Okay, 6. C6, 7. 7. So 0 to 6, there are 7 numbers of pins. And they are ADC. So basic 6 pins are ADC. I mean analog to digital converter. So you can get a clear assumption from there, or a clear picture from there. How? Okay. How many pin numbers are in analog side? A0 to A5, 6. So you can judge easily that this A0 to A5, this 6 is actually the ultimate result of the P block, that is PC block. Okay, pin C block. That C blocks actually the ultimate compact result of this A0 to A5. Now you can say why we didn't put that C block to that kind of sequence. Why these sequences are very easy and that C blocks are just out of the mind. Why? Because I said it was built at first and gradually after the improvement they will come to this shape that we are using the Arduino board right now. So if you think that okay, I will make a board and this 80 will be ultimately the result and my solution, and I don't want to use any kind of board, that will be okay. But that will be the extra bit of question from you. Just because of, let's say 0, 1, 2, C, it just contained from here, and there is another point of C, so it is not arranged to your board. Okay, so your Arduino board and this chipset is not arranged in your sequence. So it arranged to the particular sequence that we will put the analog side to the left, we'll keep the digital side to the right, and we'll make the arrangement in our own way. That is followed by the international rule. Like you can say, we know about the current, the flow of electron. So the current, I mean the I, whenever we write the I, it is just the opposite of the flow of the electron. Why? Because we always try to follow the conventional way that is acceptable to the international market, that is acceptable to all. So we are going to follow to the Arduino board that is the international format and is acceptable to all. As an engineer, you need to know these basic things. Do you get my point?
Yes.
Okay. So, okay, now there is the most important part. 80 mega 328-bit ports are divided in different sections, like port B, port C, port D, and B and D mix, and then this kind of going on the last one. Just keep aside from this port B section. Okay, so I'm going to send or upload the file to the ERP. To get to know about the ultimately UNO set, chip set in 328. That's the overall scenario. I want to know about that. Okay, so we have come to know about the basic pins of it, and gradually we are going to keep touching the other points like registers, capacitors, the microprocessor, another processor, regulator, digital pin, analog pin, the difference between of the digital pin, analog pin, why the pins are execute different kind of values. There are some special pins like SPI pin, I2C communication, TXRX pin. So how they work, why these pins are very important for us, because for particular task, as I said earlier, we have to choose the particular pins. Okay. Let's take an example that we're going to connect the Bluetooth. You can never connect the Bluetooth as your own way. If there is a portion something like that, one analog pin, so at that time you can choose from 0 to 5. If there is a connection to any digital pin, so at that time you can choose any digital pin. But for the basic, the TX pin and RX pin must need to follow according to the grammar. Okay, you can't put the TX pin to the RX to TX. RX is the receiver, TX is the transmitter. So transmitter should be connected to the transmitting part, receiver should be connected to the receiver part.